Find the values of the other 5 trigonometric functions when cos x is minus half and x lies in the third quadrant. Pause the video, try this on your own. Alright, let's do this together. We don't know the value of x, but we know two things. X lies in the third quadrant and cos x is minus half. Our objective is to visualize where x is, figure out the point that corresponds to the angle, and then we'll find the coordinates of that point to get all the ratios. Here's a step-by-step way of thinking about it. The first step is figuring out the triangle. What does the triangle look like? What are the sides? Think about cos x equals to half. Forget the negative sign. What does the triangle look like? That's our step 1. Next is, where does it lie on the unit circle? Now that we have a good idea of what that triangle looks like, we want to figure out where on that unit circle is the triangle. If we figure out the triangle, we figure out the point. If we figure out the point, we figure out the coordinates. And once we have the coordinates, we have all the ratios. Step 3 is find the coordinates. That gives us all the ratios. So let's do this. Let's first start with the triangle. Okay. The triangle. Cos x equals to minus half. Minus sign is basically telling us that it's not placed in the first quadrant. It's placed somewhere else. Well, it's placed in the third quadrant, but forgetting about the minus sign for a minute, on focusing only on the magnitude, cos x equals to half gives us this triangle. Base is 1, hypotenuse is 2. That tells us that this angle in this triangle is pi by 3 because cos of pi by 3 is half. We're not saying x is pi by 3. We're just looking at this triangle. So if this is pi by 3, this is 1 and 2, this side is square root of 3. This is the right angle triangle with one of the angles as pi by 3 or 60 degrees. Okay, step 1, clear. Where is it on the unit circle? That's our next step. Let's draw the unit circle. Let's put this basic triangle on it. This is the triangle with angle 60 degrees or pi by 3. This is the point. Again, we're not saying that this is x. This is just a reference point. This is pi by 3. These are its coordinates, half comma root 3 by 2. Okay. So cos x is minus half. Cos is the distance covered along the x-axis. It's your x coordinate. This point has x coordinate as half, but we need minus half. So basically, we're in the wrong direction. We have to go left, not right. So either we can go left and up or we can go left and down. We can have these two triangles. These two triangles will give us these 2 points, which will give us these 2 coordinates. Which one should we pick? Well, the answer is on the screen. We should pick the third quadrant because that's the other clue that's given in the question. We're looking for x that's in the third quadrant. So now we know that the triangle that we're looking for is in the third quadrant and the point that we're looking for is this one. So now that we know that x is here, we can say that the value of x is, this is pi and 60 more. So pi plus pi by 3, that's 4 pi by 3. So x is 4 pi by 3. We have figured this out. Now on to step 3, the ratios. Now that we know this point and its coordinates, we can figure out the ratios. And by the way, you can figure out the coordinates of this point using the identities that are given in the textbooks or by just observing the unit circle. Alright, now on to step 3, the ratios. We need cos, sine, tan, sec, cosec and cot. We already know the value of cos, that's minus half, that's in the question. But we also know the value of sine from the unit circle, that's minus root 3 by 2. Using these two, we can figure out the rest. Let's do that. Tan is sine by cos, that's root 3. Sec is reciprocal of cos, that's minus 2. Cosec is reciprocal of sine, that's minus 2 by root 3. And cot is reciprocal of tan, that's 1 by root 3. So we have all the ratios and we also know the value of x. Let's solve one more problem. Find the values of the other 5 trigonometric functions when tan x is minus 5 by 12 and x lies in the second quadrant. Pause the video, try this on your own. Alright, let's follow the same 3 steps. The first one is imagining, visualizing the triangle. What does the triangle look like? What are its sides? Next, we'll figure out where does it lie on the unit circle. And finally, once we have the point, we'll figure out the coordinates. That will give us all the ratios. So let's do that. Step 1. Figuring out the triangle. Forgetting about the negative sign for a while, only focusing on the shape of this triangle, tan is minus 5 by 12, which means this side is 5 and the base is 12. Hypotenuse is 12 and 5, so that's 13. That's our hypotenuse. So this is how the triangle looks. Now on to step 2, the unit circle. Let's plot our basic triangle on it. This is our basic triangle. What are the coordinates for this point? Remember that we're talking about the unit circle. The hypotenuse is 1, not 13. This radius is 1, so we'll have to scale this down. This side will be 12 by 13, this will be 5 by 13, this will be 13 by 13, that's 1. So the coordinates will be 12 by 13, 5 by 13. Now we are on the unit circle. Now where should we move? Should we move left? Should we go down? Should we take this quadrant? The question says that the x lies in the second quadrant. So I think we should move left. If we move left, our tan is negative because in the second quadrant, tan is negative. So this is the point that we're looking for. The coordinates are minus 12 by 3 because we moved left and 5 by 13 because we stayed at the same height. So these are the coordinates for this point and we now have our triangle. On to step 3, the ratios. We need cos, sine, tan, sec, cosec and cot. Cos and sine are here. Cos is minus 12 by 13, sine is 5 by 13. Tan is given in the problem, that's minus 5 by 12 and we can double check that. Tan is 5, 12 and a negative sign, so that's minus 5 by 12. Now we need to figure out the reciprocals. Sec is the reciprocal of cos, so that's minus 13 by 12. Cosec is reciprocal of sine, so that's 13 by 5. And cot is reciprocal of tan, so that's minus 12 by 5. And that's how we use the unit circle to figure out all the other ratios if you're given one of them and in which quadrant does our point lie.